right, can we get everybody to take their seats? There's lots to share. There's lots to learn. So, yeah. So, and we need your attention, right? As I told you, I'm going to show you that you are very distracted. Okay, now. So I want you to watch the video that we're going to show now. And just watch it carefully, and we'll talk about it. So if we can play that video, that would be great.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
But how did you know?
Madam, as any horticulturist will tell you, one does not plant petunias until May is out. Take her away.
Sorry, madam.
It's just a matter of observation. The real question is, how observant were you?
Right, so you've got the farm, you've got sensors, you've got your phone, you've got your camera, and many of these things are distractions. You know, I was fortunate to study the Kalahari San people. I stayed in the central Kalahari with the Khoisan. Now, if you talk about observation, those people are the best that I've seen. They are focused. They know exactly. They can read the weather. They can read. They are absolutely in tune with the environment. And that's the question. How connected are we with the environment? Or do we see it as something loose? Do we see ourselves as we humans and we not connected? Or do we see ourselves as part of the connection? Part of the existence. So let's see. I would like to ask, did anybody observe something strange in these videos? Anybody see something that was odd? Maybe you did see something, but you didn't see it. You see, that's what I told you, you're distracted. Your phone is distracting you, not focused. So let's play the second part of the video and show you what you've missed. And maybe you're missing the same thing on your farm and in your business.
And action.
Clearly, somebody in this room murdered Lord Smythe, who, at precisely 3:34 this afternoon, was brutally bludgeoned to death with a blunt instrument. I want each of you to tell me your whereabouts at precisely the time that this dastardly deed took place.
I was polishing the brass in the master bedroom.
I was buttering his lordship's scones below stairs, sir.
Why, I was planting my petunias in the potting shed.
Constable, arrest Lady Smythe.
All right. So how observant are you? Okay, so now session 2, the soil health, plant nutrition. And welcome back. And I'd like to introduce the intro note will be by Lyndon Smith, CEO of Yuma Incorporated, and Philip Garcia Gazera, Business Development Director, SQM. Discussion lead is Anli Hatton. Panelists, Dr. Estelle Kempen, Agronomy Lecturer and Researcher, Stellenbosch University, and Dr. Hendrik Smith, Asset Research, South Africa. Welcome and thank you very much.
We are SQM, a global mining company from Chile's Atacama Desert, producing minerals that improve lives worldwide. Our products include iodine, essential for health, agriculture and industry, and industrial chemicals like sodium and potassium nitrate, used across multiple sectors. A key focus is specialty plant nutrition. we provide integrated solutions that supply crops with the macro and micronutrients needed for balanced, efficient growth. Our agronomic teams, with global expertise, develop innovative solutions through research and field studies promoting productive and sustainable agriculture. Through our brands, we deliver precise nutrition for every crop. Ultrasol, water-soluble formulas for fertigation. Crop, soil-applied, fast-absorbing solutions. Speedfold, foliar solutions that correct deficiencies quickly and ensure high-quality yields. With advanced technology, global distribution, and over 55 years of experience, SQM transforms natural resources into sustainable solutions for growers and industries alike. SQM. Solutions for human progress.
Good afternoon, everyone. I'm jumping the gun. Am I? Thank you so much for your attendance and your time and your attention during this second session at the Potato South Africa Congress. Apologies for anyone who I have my back to, but hopefully you can see us all on the cameras. I hope and believe this is going to be a very practical session, but I must apologize right from the get-go. A, I am not Albert de Villiers. B, I am not a potato farmer. So I beg your forgiveness and your patience with my ignorance. But we have incredible experts on the stage, and they are here to share their wisdom and insights with you. When we hear the words plant nutrition, it's easy to think this session is simply about fertilizer programs, but the discussion is actually a lot broader than that. Potato producers today are farming in an environment of rising input costs, increasing climate variability, water constraints, pressure on soil health, and ultimately pressure on profitability. So the real question that we're exploring today is, how can potato farmers reduce production volatility and improve long-term profitability by improving soil health, making smarter nutrient decisions, embracing new carbon-based technologies and regenerative principles without taking an immediate financial step backwards? So throughout the next hour, our goal isn't to convince everyone or anyone to completely change the way they farm from tomorrow morning. Rather, it's to explore some practical steps that can help producers become more resilient, more efficient, and ultimately more profitable. Because let's face it, we're not, ons is nie liefdadigheidsorganisasies nie. No one here is in the charity business. Everyone is running a business. So I'd like to take the opportunity to allow our panelists to introduce themselves to you, just so that you know who is who. Lyndon Smith is on my left. He's the Chief Executive Officer of Huma Inc. Then it's Felipe Garziera. Am I pronouncing that correctly?
Yes. That's
Fabulous. That's great. Business Development Director at SQM. Then the beautiful Dr. Estelle Kempen, Agronomy Lecturer and Researcher at Stellenbosch University. And on the end there, last but not least, Dr. Hendrik Smith from Asset Research South Africa. I'd like to give you each a moment just to briefly introduce yourself, just to give the audience a little bit of context about the sphere of your expertise. Then we're going to go over to Lyndon for a brief introductory note from Felipe, and then we'll get stuck into the meat of the question and answer session. So over to you, Lyndon.
It's really an honor to be here. My claim to fame with potatoes is that my grandfather was a potato grower in southern Utah. His family was originally from the Swiss-German side of Switzerland. And so his last name was Barlacher. And the Barlacher family came over to the States and settled in that southern Utah area and raised potatoes. So I grew up hearing potato stories from my grandfather and from my mother, who says she sacked all the potatoes for him all her life in the snow. I'm teasing. But,
And
but
walked
anyway.
5 miles to do it.
Yes, definitely. And then when I entered into the agriculture environment, then my first experience was raising potatoes in western Nebraska in the States, where we were mostly working with seed potatoes. So seed potatoes are a fun area to work with, and I know some of you are seed potato growers. So anyway, it's a great opportunity for us to be here and share our technology. We've been on potato farms all around the world and enjoyed seeing potatoes wherever I go. I always tell everybody it's my favorite crop, it's my favorite food. Potatoes are it. So that's me.
Thank you, Lyndon. Felipe.
Well, thanks for having me. It's a pleasure to be here as well. It is my first time in South Africa. I'm from Brazil as my background. I am an agronomical engineer as well as a background with a specialization in tropical fruits, obviously. I'm from Brazil, and under irrigation and fertigation. So I started to work with fertigation in 95. You see that I'm very young. So that's, yeah. And then obviously I started to work with fertigation in Brazil with bananas and mangoes and table grapes and all these things. Later on, when I joined SQM as a company, then I started to study plant nutrition by fertigation from the, let's say, from the mineral perspective. Let's say, okay, what is the dry matter that compounds a potato or any other crop? It could be cabbage, no matter. So then we started to study, okay, from the mineral composition, how can we be more efficient to supply that one? And that's my experience with potatoes, despite eat potato salad with barbecue in Brazil. So I have a very good experience on that one as well. So I hope we can contribute with you all, and thanks really. I'm very happy to be here.
Thank you, Felipe. Estelle?
Okay, thanks for having me here as well, and yeah, gonna have good discussions. So yeah, I'm a lecturer, researcher at Stellenbosch University, agronomist, but also crop physiologist. And like Prof. Mitchell also said, I've been eating potatoes my whole life. But I've been also working with Potato SA and research for the last, 18 years, with a few detours in between. But yeah, my passion is absolutely crop nutrition, whether it's potatoes or tomatoes or berries, how they act in the plant, how they interact in the plant, in the soil, with environmental conditions, and yeah, how can we manage it more accurately?
Thank you, Estelle. Hendrik?
Yeah, thank you very much. I'm a soil scientist. I've been doing research on conservation and regenerative agriculture systems since '97, mostly in the grain sector. Currently, we're doing a lot of research with farmers on their farms, scientific research, trials on their farms right across the summer grain producing areas in South Africa, comparing different systems, the impact on soil health, production, profitability, etc. So I'm happy to share some of the lessons from the grain sector with potato farmers. Thank you.
Thank you, Hendrik. So, Lyndon, I'm going to give you 5 minutes just to spend some time introducing Humor and expanding on the approach that your company is taking.
So normally I take an hour and a half to introduce our company. So in 5 minutes, we'll see what we can do. But we're very excited to be here. Let's see if we can share the slides here. They've asked me to stay seated instead of wandering the stage. So
You're welcome to wander the
to
stage. The podium is just so restricted.
So I'll just stay here, apparently. So anyway, what we're talking about today is better soils, better health, better crops, and how we can, through our Huma technology, make a difference for you and some ideas that might be tools in your toolbox to go forward from today. So who we are, Huma is a US-based company founded in 1973. My father was one of the founders of the company. He was a PhD plant physiologist out of Purdue University in Indiana. And anyway, Huma reflects the strength of Mother Nature and the nurture of what comes from Mother Nature, as we are also miners. And what we mine is what's called leonardite or lignite or oxidized coal, depending on what you want to talk about. But it's the source of humic and fulvic acids. And I'll introduce you to another technology that's proprietary to ourselves. So as miners, then we're vertically integrated all the way from the raw material to finished products that we push out the door. And we're very happy to be, I think you saw on one of the first slides there, that we're partnered here in South Africa with Dux Agri, and appreciate the opportunity to work with them through the last several years. Anyway, to give you an idea, our manufacturing plant, this gives you an idea of our packaging side. Just a few slides here to go through. Then we have a very extensive research lab where we've focused a lot of attention over the last several years on mode of action and exactly which genes are being upregulated and which ones are being downregulated by the application of humic substances. And so that includes everything from humic acid all the way to our proprietary technology I'll tell you about in a second. But in the research lab, we've got 4 PhDs that are all part of International Humic Substances Society. And we go to those annual meetings and present at those annual meetings. This is a group of researchers that get together and talk, and we're happy to be a part of that and have our PhDs present papers and do all that kind of thing for the industry. What makes us unique in terms of Huma itself is our microcarbon technology. And where that comes from is this legacy mine that was discovered back in the early 70s by my father. And when they discovered this mine, you can note that it's a brown coal or a tan coal as opposed to a black coal. We also have a black mine I'll share with you in a minute, but this is our brown coal. And from this, we extract what we call microcarbon technology. You can see it's a desert region, but this was at one time in the Earth's history an ancient tropical rainforest where the forest would grow up, volcanic ash would lay over it, and then it would grow up again and volcanic ash, all in an inland lake type scenario. So it's very fun at the mine to see leaf structure. You can still see flowers. These are all fossilized, of course, but it's fun to be there. This microcarbon technology then is extracted from that material. And as the company was founded, we were at first just spreading 50 kilos per hectare of this raw material out of the mine. And then my father and the others said, well, let's extract out of it instead the beneficial properties, and rather than shipping, tons of this around the world, let's concentrate it, and we'd be able to cover more hectares around the world and be able to benefit more growers. And so this is a very concentrated, very special proprietary technology that we have. It's the most efficient delivery vehicle on the market. And we say that without any hesitation. We challenge anybody to take us up on that. This is something that can be foliar applied as well as soil applied, and it doesn't denature either way. We achieve far more with a whole lot less. This is all part of sustainability and not over applying fertilization. We are able to stimulate microbial populations. We're able to benefit anything that we combine with, pesticides or whatever. It's a very fast-acting source of carbon. The plant recognizes it almost like CO2. And so, as you're aware, CO2 goes in very readily and crosses that cell membrane. And what we're using is that same carbon technology to cross the cell membrane, and we carry with it nutrients, or in the case of a pesticide, we carry that along. Anyway, we talk about 1 hour absorption and being able to really dial in when we apply it, it goes right in. This isn't a slow release or a controlled release technology. It's immediate response. And so when we apply, we're able to change the plant the same day. And we've seen that in many studies that we've done. So to explain it a little bit further, the molecule size is what makes the difference. If you're familiar with humic acids or fulvic acids, we sell both of those, by the way, in liquid and dry forms. But humic acid is thousands of carbon rings typically in the chain and has some functional groups attached to it. Humic acid is, the functional groups are what makes the difference. And basically it's oxidized material, so highly oxidized with functional groups like phenols or amines and various other carboxyls, various other functional groups that are attached. Humic acids are water soluble only at high pHs, whereas fulvic acids, when you drop the pH, the humic falls out and the fulvic acid still remains in solution. So fulvic acid is good at all pHs. You can't ever have a humic acid without having a fulvic acid with it. It just depends on the percentage breakdown of that. And then what our technology does is we're refining that fulvic and humic acid to even a smaller molecule we call microcarbon technology. So we go from thousands of carbon rings, hundreds of carbon rings, down to 10 carbon rings or less. The beauty of this is you're also increasing the cation exchange capacity. In research vernacular, we talk about the electron donating and electron receiving capacity of the material. And that's one of the beauties of the microcarbon technology is we use the term complex rather than chelate. So we're complexing those nutrients on those functional groups, and they can accept both positive and negative ions. So we're able to have an effect on phosphorus, on potassium, and on all the metal ions that you might be familiar with. And I did mention about the cation exchange capacity, I think you could see there. The power of microcarbon technology in our mode of action research that we've done is it really does affect the H plus ATPase. And if you're familiar with that, it's kind of the principal, mode of action initiator that's in the plant cell. And so whenever you're able to do that, then you make a difference all the way through the plant. It increases the sucrose exudation from the roots. And so the top right, you can see the picture there on the right of the microcarbon technology and the amount of increase of exudation there. It keeps the Brix level. It produces sugar all the way through the plant. And so it keeps the Brix level high. We found that if you can maintain the Brix level in the sap of a tree or a crop, you're able to ward off a lot of disease and a lot of pests. And so that makes a difference for us in terms of root health, plant health, and development. It supports auxin activity as well, so you're getting more branching, more fine root hair development when applied to the soil. And I'm going to take too much time. So
and I'm watching the clock count down.
Oh, that's the clock.
Yeah.
I can't see. It's a good thing I can't
Felipe
see it.
still needs to have his
Okay.
turn.
So anyway, Huma has developed a whole line of products that are developed based on this humic technology that comes from what we call microcarbon technology. We combine it with essential nutrients and other biostimulants to form our finished products. And I'm going to probably have to leave it there, other than just this last comment that carbon is the most important nutrient in a crop. So if you boil down or dry a crop, carbon is the number one element, 46%. is what they say is going to be carbon. And so if you have a nutrient that is complexed with carbon that can be the transporter or the vehicle for that nutrient across the cell membrane, you're going to have a much more efficient nutrient. So we have more efficiency, so nutrient use efficiency. We're able to stimulate with some of our products the different microbial communities. One product that stimulates bacterial growth in the soil, another one that stimulates fungal dominance. So there's a lot more that we could share with you, but we're out of time. So we appreciate the opportunity to be here again.
Thank you, Lyndon. And I'm sure we'll have more time during the discussion to get out some more about carbon and the benefits. Felipe, over to you.
Okay. As soon as, let's see, well, the idea of the presentation is do a quick introduction in less than 5 minutes, I hope. So about the way as we work in the company to approach the plant nutrition with our minerals. So I'll go quickly. We always start studying the nutrient uptake curve and the nutrient composition. So in average, 1 ton of potato needs 3 kilos of nitrogen, 7 kilos of potassium as element, as chemistry. So this is, we can, with the expected yield, calculate how much of these minerals I needed in order to have a good yield with good quality, and then how to spread along the cycle. What this shows to us, 2 most important things in this graphic. One is that potato is one of our favorite crops because it already starts since the beginning with a higher demand of potassium in comparison with nitrogen. If you compare with most of all the other commercial and agricultural crops, it's not like this. Most of the crops start with a higher demand of nitrogen, and then normally after flowering switch on and demand for potassium increase. So potato is a kind of special case in that sense. This is something that we need to take in consideration. The second one, you see in this example, consider a 160-day cycle. If you look at the peak of concentration, potassium, nitrogen, calcium, in order to have the peak of dry matter, we have 70 days from sprouting to really reach that peak of supply, that minerals to this plant, in order to produce a good dry matter content. It is 70 days, it's not 160. Because we needed to have that amount of nutrients in most of their amount at that stage available to the plant. One thing is have the nutrients in the soil. My colleague later on can tell. Another thing is have them available to the plant uptake. And perhaps your technology can help with that. Yeah. So this is thing. There is plenty of studies on that. I will not spend too much time. This is a different study, but basically showing the same thing. You see a higher potassium curve than nitrogen than the other elements. So an important point for us from the chemistry perspective as well, okay, we know the minerals, we know how much and when we need to apply it, but how can we be efficient? Consider the simple principle, antagonism and synergism. If I apply most of my nitrogen as ammonium, as a cation, it's an antagonism with the other cations. If I want to have synergism, how can I be efficient with nitrogen and potassium? One of the most efficient way is using nitrate nitrogen, just because negative and positive charges. It's not about products, it's not about nothing. It's cations and anions. It's pure chemistry. It's positive and negative and balance. Plants needed to uptake nutrients in balance. And the other anions we have in a fertigation solution, it's basically phosphate and sulfur, that in a very small amount. So nitrate nitrogen, it's basically the main tool we have, just to add negative charge in the nutrient solution to make it easy to the plant uptake nutrients and then make the fertilization scheme more efficient. As well, if you have chloride programs, you have a second benefit. If you add nitrate nitrogen as an anion, we'll avoid the uptake of chloride by the plant. Chloride will stay there in the soil, but will not be uptaken by the plant or by the potatoes in this case. Sorry, this is a tomato plant, it's not a potato. So, and then plenty of studies that's showing the difference you can see on the impact on the yield, regardless the nitrogen rate. You see 3 different nitrogen rates here in this study, with 3 different as well, and on the yellow, blue, and green color, 3 different rates. And you can see clearly that regardless the nitrogen rate, always when you have it 20% ammonium, 80% nitrate, you have the better result, the most efficient one. And this was also proved here in South Africa. This study was conducted partially by our colleague, Peter Brink, that is just over there. Thank you, Peter. It's glad to share this with you. So it was done this in South Africa, repeating, and that is the same. You can see that regardless the nitrogen rate, always the 20% ammonia and 80% nitrate deliver the best performance. So regarding solubility, for the ones that doesn't work with fertigation, as well, one important point with the source of fertilizers is that the solubility. As you saw, we have 70 days to deliver most of the nutrients to a potato plant. So when you apply a nutrient, it's very important that the solubility is quick, so then the uptake can be also quick. So compare also the solubility between the fertilization sources that you are using. We did also a study in Poland that showed many of the benefits that I show you, but we can detail this later on in our conversation. So thank you for your attention, and I hope I did it.
You did. Thank you so much, Felipe. Appreciate that. Lightning speed. Let's give them a round of applause. So we're going to have to make our conversation a little bit more concise. Hopefully the guys at the back are going to be nice to us and add another 5 or 10 minutes onto the back so we can really get into the meat of it. But let's see how far we can get in trying to really get to the core and distill our understanding of when we talk about plant nutrition. What are we actually talking about? I want to start with you, Estelle. And in asking what the real problem is that we're trying to solve, is it nutrition? Is it declining soil health? Is it increasing climate variability? Or is it really about helping farmers reduce risk while maintaining profitability?
So, I think to answer the question, also linking back to what you said in the beginning, is that farmers are facing a combination of risks. It's not just water or just climate or just soil. And that also means that our solution to these problems will have to be integrated. And I think that's one of the key things. We can't only look in isolation at one thing. So, for example, we just want to increase yields, or we just want to reduce the pesticides that we use. All of these things are interlinked. And if you fix one, or if you don't fix one, also the other way around, it's going to have a knock-on effect on something else. So a bit away from your direct question, but I don't think we can single out one single problem or one single solution, but we have to start looking more holistically at the whole system. And we have a lot of different tools. We listen now to some very interesting new developments. And we have to make use of all these tools to build into our toolbox.
Okay. So having not spent a lot of time on farms, I've only been in agriculture for 5 years. One thing that stood out for me when talking to a farmer for a television program is he said, God created soil once. It is what it is. If you deplete it, new soil isn't suddenly going to fall from the heavens into your lap that is richer and provides better nutrition for your plants. So you've got to look after your soil. And there's a couple of ways we can do that. But as someone not in agriculture, I wonder, what does healthy potato soil look like? Estelle, Hendrik, from your experience, how do you identify it?
Potato soils. You better ask.
Estelle?
Again, I'm not going to answer your question directly because our farmers will also know there's no one potato soil. We work with very many different soils. But the key is to know what soil you do have and what are the limitations in my specific soil, whether it's really sandy soils or heavier soils, what's my limitation, and then start to find the solutions to try and improve that soil. We're going to get later to resilience, but your resilience in your farming, in your crop system starts with your soil. And resilience means the ability for that soil to buffer any stresses, whether it's from environment, whether it's from nutrition, and it can be too much, too little, water, pests. Your soil acts as a buffer to enable your crop to handle that.
Yeah. Hendrik, I'm going to throw this one to you, and you can add on to that if you want. But when we're talking about soil health for potatoes, we're talking about more than simply holding nutrients. What role does biology play?
Sure, yeah. I think coming back to your first statement is the soil was just created once and be losing that. Our measurements under cropping soils in South Africa shows that we've lost 50% on average of our carbon in our soil. In some cases, even as high as 75%. So we need to reverse this downward cycle of soil degradation and build those functions and services of soils, including more biology, more carbon, more nutrients, balanced nutrients that will lead into production, sustained profitability. But biology is 100% part of it, with chemicals, soil chemics, as well as soil physics. So you've got to look at all the elements of soil, and when you build up soil, all those elements will form part of that restoration process.
And gents, I haven't forgotten about you. We're coming to you shortly. Before we get there, you will have seen on your programs that the subheading for this discussion was 4R or 5R. Now, I had to go and do some reading to see what the 4 R's of soil nutrition are. So, right source, right rate, right time, right place. And we're going to look at what that 5th R could possibly be with you guys in just a minute. But Estelle, before we go there, I want to find out, where do farmers most often get it wrong?
Again, I'm going to reiterate your question there, because I don't think they get it wrong. But what I think we have to start doing better, and again, linking to our conversations from this morning in terms of climate change, and also linking to Felipe's presentation now, is linking, what we apply to the crop. So we know that we have our fertilizer program, so we know what the crop needs. We know kind of when we have to apply it. But with all the changes that's happening, we have to work to a more dynamic model. In other words, I have to know at this point in time in the field, what does my crop need? Not what is it supposed to need based on the theory, but what is happening in the field now, and act according to that. So that would be, my big advice is just don't, stop following just a standard program, and monitor what's happening and act according to that.
So it's not just about, more inputs. It's about better decision based on localized information, just tying into what Gabrielle said in the first discussion. You've got to have the data to know what your conditions are to make better decisions. But coming back to the possibility of that 5th R, Lyndon, where does carbon fit into modern potato production?
Yeah, we always tease that there's 5 R's, right source, right time, right product, and right application. But then the 5th R is right carbon source to add to that. And then that becomes the delivery system for everything else that you do. So we find that with the right carbon, we can stimulate the soil to regenerate itself through stimulation of the biology that's there. We talk about inoculums that could be in the environment. There's plenty of biostimulants and inoculums on the market. But we always say, from humus' standpoint, that if you're going to use an inoculum, you want to send it with a sack lunch. And that's what we can help do, is provide a product that stimulates bacteria, or a product that stimulates fungi. And so for row crops, bacteria are most important. For potatoes, bacteria. For trees and vines, it's the fungi. So we find that with the right biostimulant and biostimulation, you're going to get that soil environment to move around. The best soil for potato is if you're in heavy ground, that the soil actually falls off the potato when you dig it. And for sandy soil, it's that it will hold together enough to keep the nutrients and to keep everything going. So it's not just hydroponics and you're just flowing water through the system. So both of those can happen with the proper balance between bacteria and fungi in the soil, and we can help with that.
So it isn't replacing good agronomy, it's just strengthening the system
That's right.
around it.
Yeah, working with Mother Nature. Yeah.
Absolutely. Everything we've discussed so far sounds positive, but of course, we're coming back to the idea that farmers have businesses to run. So, Felipe, you've made the point in our sort of off-air preparation for this discussion that sustainability only works if it's profitable. Give us your insights.
I am a farmer also. So with my family, I am a mango and table grape farmer in Brazil. So I know how it hurts in the pocket. We used to say in Brazil that it's the most sensitive part of the human body. So
the pocket.
Yeah, it is the pocket. So the point is, let's think in a way, for example, we have the Green Revolution, I think it was in the 60s, 50s, 60s or 70s, I don't remember. But then where the chemical fertilizers made it a huge thing and bring us till here. So now, these days, we have all the full set of biostimulants and new technologies, as you just presented to us, Linda, that is supporting us on that. And the point, it's really not replacement, because all the trials we did in our company, when you combine our mineral fertilizer with organic substances, the result goes up. It's better than only mineral and better than only organic. When you combine both, that was always delivered to us the best result. And from that perspective, I don't see that any new technology or new product, I'm sorry, my fellow colleague farmers, will be cheaper. I don't think that will happen. So we will not reduce cost. I don't believe on that. But I do believe that we can increase yield, productivity. So then with some investment in technology, we can harvest more and then increase our profitability. So on my view, the way we can increase our profitability, how can we increase yield, productivity, efficiency in the field, combining the technologies that we have today. So, and for me, that's the key point as a farmer. This is what I look into doing my farm. So it's not how can I do it cheaper. Okay. My father especially is always thinking on that. So that's his task. But as an agronomist, let's say as the consultant of my own farm, how can I be more efficient and produce more? So the best way for me to reduce cost is dilute that cost for more kilos per hectare. So then I have a lower cost per kilo produced per hectare. So that's for me, it's my target, what I'm looking for.
So you find cost per hectare is your key metric for success?
Yield per hectare is the key, not cost per hectare.
Okay.
Yield per hectare is the key. Yeah.
But the cost per hectare is going to determine
the
your
cost.
profitability.
Exactly. I can give you an example. For example, for my mangoes, I have a cost of in dollars that would be 35 mil reais divided by 5. It's something around $70,000 per hectare. That's my cost per hectare of my mangoes. If I produce 20,000 kilos or 40,000 kilos, the 35 is the same. So I needed to improve my kilos. I needed to be more efficient. The 35 will not change. But 20 tons or 40 tons, that will change, will impact my cost and consequently my profitability. So more kilos of potatoes per hectare, please. That's it.
Lyndon, you wanted to interject.
I was just going to add, agree 100% with what he's saying. The key there is also to increase the nutritive value. And so if you do a balanced nutrition, that's where you really changed the quality of what you're producing and the nutritive value for each other. And so if you treat it properly, just like we talked about for potatoes, potassium and calcium being very critical, that increases the quality of what you're producing. So you get rid of hollow heart and many of the other, diseases that happen if you're treating it with good nutrition, a balanced nutrition program.
Hendrik, regenerative agriculture has become one of the biggest talking points in agriculture. But potatoes are different. They require soil disturbance. There's no getting around that. So what does regenerative agriculture realistically mean for potato producers who want to use these combined methods of ensuring their soils are as healthy as they possibly can be to provide the best buffer in this sort of time of increased volatility?
Yeah. I think there's two facets about it. So the first one is what you do in this potato season. And that's where these experts and many of the farmers are very big experts on. So it's the 4 and the 5 R's. That is what you do in the potato season. There's so many things, I guess, that you can do then. But what is equally important is what you do between the potato seasons, and that's where the regenerative agriculture principles comes in. So it's also the periods of the rotation in between the potato seasons, which should be as long as possible. At least 4 years, 5, 6, 7 years. And what you do then is becoming really important in terms of applying the principles and practices of Regen Ag as best as possible. And it's also farmers know it as good farming principles and practices. You can call it whatever you want, but the principles that we follow, and you will recognize them, is as little disturbance of the soil as possible. That means mechanical, chemical, and biological disturbance. Cover the soil as much as possible. Diverse crop rotations that include multi-species cover crop, permanent or annual crops, and livestock integration, as well as living roots in the soil as long as possible. Those are the principles, and every farmer is then open to test and adopt those principles in that rotation period as best as possible. And every context different, every field differs. So they will have to start and test these principles. And if they get it right, they will be able, and that's a guarantee, they will be able to restore the soil health after the disturbance during the potato season. They will build up carbon, they will reduce diseases, restore the nutrient balances. All those soil health elements will be restored if they are able to apply these principles in that rotation period as best as possible. So that is the core message. It's really about the potato season, but also the rotation season in between the potato seasons. That's where you really need to concentrate on the CA-RA principles and practices.
2 questions in one. Is it profitable? Does it make money sense? And where should farmers start? Because it's not just okay, now suddenly from tomorrow morning, we're doing Regen Ag, we're changing everything that, you've got to sort of integrate that into your approach over a period of time, correct?
Like Philippe said, it must be profitable. And it will be profitable if you do it correctly. So you will have to measure your profitability per hectare, and obviously yield is a big factor in terms of profitability, but it must be measured over that whole rotation sequence over time. So it's not about the potato season only, it's about the 4, 5, 6 years rotation cycle. And building up soil is part of your sustained production and profitability. If you don't look after your soil, if you don't restore your soil in that period, your production and profitability will go down. That's a given. So yes, absolutely measure, make sure that your systems in between the potato season is also profitable. And we did measure it in maize in the grain production systems. When you do it correctly, it's much more profitable than simply conventional or normal rotation systems.
I want to give a quick opportunity before we go to the floor to get some questions for some myth busting. And this is maybe not something we had discussed in our preparations for this session, but I think there's a lot of value from your expertise in various areas to highlight each of you in turn one myth about soil nutrition that you've come across that gives you the biggest headaches in trying to offer farmers solutions or a deeper, more comprehensive toolbox. If I can start with you, Lyndon.
Yeah, I think the biggest challenge for us is that there aren't enough microbes out there in the soil. They're there. There's plenty of them there. We need to feed the beneficial microbes, stimulate those that we already have, and really help them to do the work that Mother Nature wants them to do. And so I think if there's one takeaway for soil health, regenerative ag, it's that there's plenty of microbes there. We just need to feed them properly, treat them properly, and they'll give back a whole community that gives back as we produce whatever crop we're producing.
Felipe?
Yeah, I think from the mineral nutrition perspective, and I talk about our business, it is, let's say, from the mineral nutrition, normally people have a fertilization scheme established. And for me, that's the worst thing to have it. So they have a kind of program, a recipe. That's terrible. Because the mineral nutrition, it's about, okay, how many kilos of that element 1 ton of potato need. So if you produce 25 metric tons in one amount, 50 is a different one, 75 is a different one. So we needed to really go to the field as agronomists or as farmers and have a clear idea, what is the expected yield of my field? Will I harvest 50, 70, 100? In US, they have some areas around 100. I don't know here in South Africa the average, but because it's from the science and chemistry perspective, it's the dry matter is kilograms of nitrogen, phosphorus, potassium, calcium, whatsoever per ton. So we need to adjust the fertilization scheme according to our expected yield. If you allow me, quick example in Brazil. In Brazil, once a potato grower, that is a potato example, approach us, now I want to increase more yield, I need more tubers per square meter. So we design a program in order to improve zeatin production. Zeatin is a kind of cytokinin, so then more cell division, so then more tubers per hectare. Great, we achieve it, but the fertilization scheme was not adjusted. So we have more tubers, they don't adjust the fertilization scheme, small tubers. So then the industry doesn't have it. So if they adjusted the fertilization scheme, it would be a full success. It was a tragedy on that time. So forget about the recipe of the fertilizer. So just according to your field, probably you have different fields in your farm. You have one field that you harvest 40 metric tons, and probably another field that you harvest 60. Fertilization should not be the same. So adjust the fertilization you have according to the expected yield to your field. That will help on the profitability and perhaps reduce a bit the cost.
Felipe, South Africans dream big, and I don't think our farmers have enough money to put the kind of fertilizer down for the yield that they would want to achieve with costs at the moment, but I get the principle. Thank you. Estelle, myth busting.
I think mine links actually with what Felipe is saying, and that is the more is more. I think we're realizing sometimes less is more. And if we just talk about this in terms of mineral fertilization, I think one of our key culprits that we're seeing, which is a necessary evil as well, is nitrogen. We need nitrogen. The crop obviously needs nitrogen, but too much nitrogen can actually cause more damage than you realize, because it affects not only your crop physiology, it affects the growth rate, which affects the rate at which other nutrients is being taken up. So sometimes we have to slow down to get more out, specifically with nutrition.
Thank you. Hendrik.
What we see is that it is not about only soil chemistry or biology or physics. It's about all of it. If you only concentrate on the one thing, you will at one point realize, but the things are not moving, things are not changing. Then you realize, okay, but the soil chemistry and nutrient balances and pH and soil structure chemically wise is not in place. So you've got to look at all three elements and make sure and monitor and see that they all are okay. Otherwise, the biology won't change. The carbon won't change if your soil chemistry is not in the right ratios, etc.
So part of the reason why it would have been far better if Albert was here, and he's unfortunately sick, he didn't just dodge the panel, is because he's a farmer. He would have been able to bring that back to the field, to practical applications, to challenge some of these things. I'm going to try and attempt to do that by getting each of you to give us a practical way in which all of the producers sitting in the audience here can make perhaps one small or consistent or financially achievable change from tomorrow.
try our products.
Felipe, you can't say the same thing.
Oh.
Okay, you can.
No, I think one of the speakers here before mentioned something regarding that the farmers needs to know what's happening in your own farm. We have a lot of general data. I think if the farmer really gets to know better his own farm, so then he will be able to find perhaps the best solution and the best economical and profitable solutions as well. So it's good today with the internet and everything. We have access to a lot of information. So we needed to be able to, okay, this is a lot of all this information is available, but for my reality, for my situation, okay, what is the best approach? What is the best thing to do? I think really get to know your own farm. I think this is something that you can do better for yourself tomorrow as a farmer.
Absolutely. And luckily, there are so many producers in the same production regions as you, and I'm assuming you all talk to each other anyway to share challenges and share some of the successes you've achieved with different strategies. Hendrik, a small change that can start a farmer's journey to regen ag.
Yeah, I agree with Philippe that you need to invest in knowledge. You need to build up knowledge, spend enough time learning more about soil health. But a very practical, profound step forward is to start to test it. Let's say regen ag principles focused on soil health, test it on your own farm. Do experiments, preferably scientific experiments with technical partners out there, but start to do on-farm trials and measure it properly, analyze, integrate all the data, and that's the best way to learn. You learn, you practice, and then from there you can scale it out to the rest of your farm when you are really confident in doing that.
Okay. So now it's time for co-creation, innovation, and you will have far more practical questions than I have had up until this point, and be able to put very specific situations or examples to our experts to see what they would do in a given situation. If you have a question from the floor, please raise your hand. We will bring a microphone to you, and then we can make this a really nice, engaging session. We've flown Felipe and Lyndon all the way here from across the world. You won't have them again for another 2 years, if not longer, so fire away. There we go.
Yeah. I have a question for Dr. Smith, but I first want to make a statement. I think being in the fertilizer business and plant nutrition for all my life, and the question you always get is, give me the cheapest fertilizer program that you can give me. And I think a statement on that will be, the cheapest is the one that a plant is using. So what can we do to enhance the plant's abilities to use the fertilizer or the nutrition that we're giving to him or to eat? I think this comes back to, do we have root development, right? Root development, stuff like that. So that's the important thing that it all boils down to. The question, Hendrik, is we talked about soil health, and if you can't measure it, you can't manage it. So the question is, how are we going to measure soil health? What's the indicators that's available? What tests can we do? We've been doing precision farming for a lot of years. We do all the soil samples. So what can we do extra in this whole process to get more out of our soil testing?
Oh, that's a very good question. Yeah. There's so many very good soil analytical tools out there in labs. So there's lots of service providers, even in this room, that can supply you with a wonderful set of soil analysis explaining something about soil health. So, and you've got to make a bit of a study of all these different options. There's every year there's a couple of new ones, and you need to decide, okay, this is what's going to work for me. But one first suggestion is just add carbon analysis on top of your chemical analysis. Most farmers don't even have carbon analysis. And you will learn so much more from a soil health perspective, just by adding carbon measurements. And then obviously, biology comes in. There's a lot of wonderful biological analytical tools that you can use and measurements and soil physics. So try, if possible, measure the chemistry, and we're going to hear about that in a panel after this. Biology and physics. See if you can measure all three and develop a sampling framework and a monitoring plan for your farm. I don't want to spend more time on that, but it's really important. If you don't sample correctly, you will have wrong information. Get your sampling framework, your monitoring plan, and analyze regularly, at least once a year. Build that database of soil health. Try to analyze it as best as possible, get people in to help you, and then integrate it with production, profitability, weather, all the other data sources that you have, that you can have a comprehensive analytical decision support tool helping you. I hope it answers your question.
Thank you.
Might I just add something there?
Yes.
What I've seen also before is when producers start on this journey and they have all this analysis, the physics, the chemistry, and the biology, it might be overwhelming. And I think the suggestion is also just pick the one that's going to make the biggest difference. Exactly. and only work on that for now. And then you can pick the next one and then the next one. Do you agree?
Exactly, 100%. Don't make it too complicated because it can be overwhelming, 100%. Select your one or two methods that you like and you are comfortable with and you understand. And then just go on with that and develop your framework, your plan and database regularly.
If I can add something from what Kuni said earlier, and this is just like a philosophical musing, it's not really based on any kind of science, is that if you pick what works for you, don't forget to challenge yourself every now and then to throw a difficult question your own way and to say, am I maybe missing something? So that you've got something that works, that's repeatable, that you're adjusting as needed, but you're trying to be a little bit innovative now and then, because like he said, if you're trying to create the perfect candle, you're never going to develop a light bulb. Any more questions from the audience? Yes, we've got someone over here.
Yes, sorry, I'll maybe just come a little bit forward so that you can see.
That's great. Thank you.
Werner de Klerk from Corteva, for these that don't know me. So while we're speaking about climate change and all the innovative ideas and naming one or two things that you'll do to change, so maybe Philippi, to ask you a question as you're a farmer yourself. And I think this is a question that we as farmers and agriculture advisors get quite a lot often in the field, and with El Nino coming as a possibility and getting more drought and higher temperatures and climate change coming into effect. I would ask you, so if let's say next season gets into a turmoil of drier conditions, it's a lot hotter. Do you apply? Do you not apply? How do you combat against that stress? Because there's a lot of companies that's here that's got excellent strategies, but how do you convince a grower? And as you're a grower yourself as a farmer, how do you make that decision of versus applying or not to apply? Because if I was a farmer myself, if it's dry, you do face that factor of do I apply, do I not?
Thank you for giving me the most difficult question for now. So. Really appreciate that. But I think, first of all, I think as a farmer, as farmers, we are dealing with nature, and it's very difficult fight against nature. So honestly, first of all, we need to understand what is the impact that it's coming with the climate change. Could be a drought, excess of rain, or anything. My way of thinking, and then really I will answer with my way of thinking as a farmer. First thing I think it's okay. Can I go over this challenge? What's happening? It could be excess of rain or excess of drought. Do I have water for irrigation too, if I have exactly like no rain, zero rain? Do I have water for irrigation to make the season? If the answer is no, I will not apply. Do nothing, because If you really no rain and I haven't a tool to overpass that challenge, you're not. Yes, I do have water. It's not the ideal, but I do have maybe 50% of the water that I need, for example. Okay, can I use other tool like mulching, or today we have a lot of different substances that we can add in the soil in order to keep water and retain and then perhaps reduce the effect. Okay, let's do it. But my first thing will be, what is the challenge that's coming? And in the worst case, can I overpass that challenge? So then I will do everything that I can to do it, because I am a farmer, I never gave up. But if I already know that the answer is no for that question, then okay, I will not spend more money just to spend more money, knowing that I will not be able to really overpass that one. Not sure if this is the answer for your question. But Lindo, do you want to add something?
Yeah, I was just going to add, the whole concept of biostimulants in the agriculture community is to exercise the plant a little bit before it gets stressed. So just like we would go to the gym and we exercise our bodies so that when we're under stress, we have the ability to overcome that stress, we can exercise the plant through biostimulation to be ready for a drought. And so you're making it more drought resilient. So we talk about, at Huma, we talk about giving the plant what it needs to be able to bulk up and be ready for a stress. The best insurance you can buy is a good biostimulant that will prepare the plant for whatever comes along, whatever abiotic or even biotic stress it might be facing during the season.
We've got 2 more questions. We've literally got 1 minute and 15 seconds, and I've already asked for more time. We've got one from this side. Thank you.
Sorry, I don't quite know who to channel this question to. But if none of you answer it, I fully understand. Glyphosate, how does that interact with soil health? I mean, it's we're using it very liberally worldwide. What is your take on the use of glyphosate and how it's affecting soil health? Thank you.
I didn't get you. What is?
Do you want me to take it?
Glyphosate.
Glyphosate. Yeah, okay.
I can start. Go ahead.
No, but look, I'm not from that industry itself, so I really work with plant nutrition. Not too much that I can add on that perspective, but my experience using chemicals. In general, the problem with chemicals is not with the chemicals itself, but with the farmers, because the farmers doesn't use the chemical properly. And normally in industry, when there is developed a chemical and got the license to do it in general, let's say if they are used properly, we can have, let's say, we could have some damage, but normally the benefit is higher than damage. But I know farmers. Farmers, okay, I use 10 millimeters of this and have a great result. Now you add 50 millimeters because then the result will be even better. And then we start to have the problems. So that's a bit of my practical experience with chemicals. But Lyndon, please.
Yeah, I was just going to add that I agree with that 100%. We tend to think a lot more is better, like we've commented earlier. But whenever you have a herbicide or any kind of pesticide that you over-apply, then you get resistance in the environment. Mother Nature creates her own ability to overcome that particular pesticide being applied. And so one of the things that we do is to add our microcarbon technology into pesticides that helps overcome the resistance that's generated. So I'm not talking about how negative the glyphosate may be in the environment itself. I'm just talking about being able to get it to do what it's supposed to do. We can help with that. On the other hand, we can also break down additional pesticide residues in the soil so that it's not dinging our biology. And one of the ways we do that, of course, is using this microcarbon technology. So I'll be quiet.
Thank you, Lyndon. Vili, you've got a question, and if you ask a question, we're not going to get in trouble because it's your Congress.
Well, it's more an invite and maybe a clarifying statement. You know, when we did the panel preparation, I heard Felipe saying there's something about, going for increased yield. And as agricultural economist, that usually lets all my hair in my neck stand up, right? Because that's the one thing that we've tried to avoid is for people to chase yield. So what I've found today, and I just want to make sure that we've got it on the same page, increased yield with the same inputs, not with more inputs. In other words, doing different things with the same inputs to allow yourself to have increased yields. Otherwise, you have to reduce inputs to get to the same yield to create the same margin. That's the one point, and the other one is just an invite from our side. These gentlemen has travelled, as we said, all over the globe. We've got a short period of time with him. Please engage with him when you've got an opportunity.
Thank you, Veli. Right, so you've got big time is up written on the screen here. So, ladies and gentlemen, I think we've heard a consistent message throughout today's discussion. It isn't about applying more fertilizer. It isn't about following the latest trend. And it certainly isn't about asking farmers to completely reinvent their businesses overnight. It's about making better informed decisions, looking after soil that supports every crop, and using nutrients more precisely, taking advantage of new technologies where they make practical and economic sense, and measuring what really matters. So thank you so much for your attention. Thank you to our panelists, Lyndon, Felipe, Estelle, Hendrik. We really appreciate your insights. And that's it from us for now.
Thank you.
Thank you.
Thank you.